Alright, in this problem, we're talking about transformations. We call these power functions. Everyone say power functions?
Power function.
Klaus, what's the exponent up here? A 1, and then you have a what?
3, 4.
Right? I don't know, we were playing Mario Kart the other day with the kids, right? And then you have a special power. And then you can use that power for like 5 seconds, and if you have that power, then you go like super fast, right? Your shells can shoot out faster. Now here it tells us the function a of x is equal to h of x plus 2 times g of x. So if you have colors, let's highlight something. So I notice h of x here, which is up here, which is a cubic function. There's my cubic function. Okay. And then I can just highlight this whole row. And then I notice that it's 2 times g of x, so g of x is just x squared, which is a quadratic there. Therefore, I notice in this problem that I don't need all these other functions. A function g of x and h of x are shown. Complete the table. So there's a verb, complete the table. And number 2, sketch on the coordinate plane shown. Okay. So it says the first row has been completed for us. How do they get this -8? Well, I just take my x value, which is -2, and I put it into my yellow function. -2 cubed. Now, this is incorrect. This is incorrect because when you do a substitution, we learned in the beginning of the year you should be using, what should you be using? Parentheses. Why is that a big deal? This is really -2 times -2 times -2, which gives us what? -8. Okay, so if you're doing this by hand, do that. Okay? Now g of x. G of x is in green. How do they get this 4? Well, I take x equals -2 and put it in there. Class, what's -2 times -2? +4. Then it tells me it wants me to compute a of x. Well, a of x is h of x, so let's write that. H of x plus 2 times g of x. What does that mean? I'm just going to place my yellow row here, my green row here, but I'm going to have to multiply all of those by 2. Okay, so let's do the yellow row together. Class, what's -1 cubed? -1. And notice how you can even go to an x value of -1 and try to find that on the graph. Does that make sense? This is a visual of all of your answers. If I put in 0, what do you get? 3? 0. If I put in 1, what's 1 cubed? And 2 cubed? This is how I got those values. G of x. I'm going to put in a negative. We already did -2. -1. -1 squared? 0 squared? 1 squared? And 2 squared. 4. Okay. So now I'm just going to repeat this yellow row, h of x, over here. And then I'm going to repeat the green row, g of x, but before I do that, I'm going to write +2 and then so g of x, 4, 1, 0, 1, 4. Now my new function is called a of x. And I want to compute a of x by just applying these math operations. So, -1 plus 2 is 1. 0 plus 0 is 0. 1 plus 2 is 3. 8 plus 8 is 16. So what I can do now is I can graph this. Complete the table. Done it. Sketch it. Let's do it. I have negative 2, 0. Negative 1, 1. Zero, 0. 1, 3. 2, 16. Use pink. Highlight something like this. Alright, so I've completed the table. I've made a sketch based off of my x values and a of x. Now, I'm just going to answer questions B and C. Write the equation for a of x. So a of x, let's just copy it. H of x is what? Look above. What function does it tell you? X to the third. And g of x is what? U. What is it? X squared. So my new function, a of x, is equal to x cubed plus 2x squared. Explain any differences between the graph a of x and the graph of the basic power function of the same degree as a of x. So it's saying, well, this is, I'm looking at this is transformed, right? Something's happened to it, and this is a cubic function. So we can talk about end behavior. Starting up, starting down, ending up, pink. I can talk about, well, the x-intercepts might be different. I can also say that the minimum and maximums might change, and then where it's increasing and decreasing also might change. So on this problem, use highlighters.